Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I will be your moderator. Our guest today is Barry Matsumori, CEO of a company called Bridgesat. Bridgesat is a company that's enabling future space missions using optical communication solutions through a global network of ground stations and complementary satellite terminals. During this episode of Constellations, we'll talk about optical communications and how it's different than traditional radio frequency, RF, or fiber networks. Are you ready there, California kid? Are you ready to go?
Thank you very much.
Okay,
Happy
great.
to be here.
Let's start by talking about what exactly is optical communications.
Oh, that's great. So everyone knows RF. RF is what our mobile phones use, what most networks use. But what's different is the ability to do the same sort of transport of information using photons instead of electromagnetic waves.
Pretty simple for a physicist to understand. What can the person on the street, comparing it with the lasers, or similar, dissimilar, or what's the difference?
Actually, all kinds of people have practiced at some point in their early career the use of communications by simply taking a flashlight and turning it on and off.
Well, that's communications.
That's communications. It may be slow, the bit rate's very slow, but it is optical communications. And then if you speed it up where you're using something like lasers or LEDs, and then using a modem to modulate the signal, you can get a lot of high-speed data.
A lot of it. Okay, so traditionally, here we're at the floor of Satellite 2019. Everyone walking around here, seeing what's going on, listening to people on panels like the panel you're going to be on real soon. They pretty much know what RF communication is all about. Yes. And so would you lift and shift and kick out RF and put in your system, or would you augment RF, or where does it fit in the matrix here?
Now, it's a great question because by all means it is complementary. RF is here to stay. It's never going to go. But there are times and places where one needs security as a feature, one needs very high speed as a feature, one needs a lot of capacity. If any of those apply, you'll think about doing something other than RF, or at least complementing an RF system.
I guess if you have a Honda Accord in your driveway and you got 12 family members coming over, you rent a bus or something, huh? So
yes.
You use this for specialized applications where high speed's required?
Maybe the metaphor is you have a Honda Accord and then there's a Porsche also available.
Oh, that's what it is. Of course, you'd call it a Porsche instead of a van. These California people, they think about Porsches and Lamborghinis. That's not the top of their head here. So we know that you have a faster solution for communications here. So where's the market for optical communications? How big is it? Who are the customers? And what's the projected growth rate?
Right. So market-wise, that's a great question because we're here at a space conference, at a satellite conference, and the applications for space are very clear, but there are applications for air, and there's applications for ground-to-ground communications. And if you combine air, space, and ground, the market is large. I'll say it that way.
Last year, you were on Federal News Radio and talking about your company. So there's a federal market there too. Is that correct?
Oh, very definitely. We've actually, since we've last talked, we've increased the number of government programs that we have because there's definitely a national need for this capability along with the commercial need.
When you talk to people at the DoD or other agencies, the first word comes out of their mouth is going to be cybersecurity. What do you want for lunch? Cybersecurity.
Super important.
And so where does cybersecurity fit in with this type of technology?
So let's talk about what cybersecurity is. It's a number of protocols, a number of processes, and then it also includes things like encryption. Encryption, by its very definition, means you protect something because the signal got away to someone that may be an unintended target, unintended receiver. And what we try to do is we try to add layers by getting a signal only to the intended receiver, and that way you can apply encryption also, but it's a layer. And that's the big security aspect that optical communications provides.
It seems like it's related to this federal concept called zero trust. It's only allowing certain people access to certain documents in a certain situation, and they're pre-vetted, and then it's almost reluctantly releasing the information to that person.
Yep.
A reluctant release. Changing the way people do things, changing the way people think. humans don't want to change. They're emotionally committed to, we've always done RF. So my question to you is, can your system have that kind of a transformational effect on the business model for the government or a commercial company?
I think that's probably one of the key questions, because it is a change. The entire community that's walking around here for a very long time has done nothing but RF. And the notion that photons are augmenting, possibly replacing in some circumstances, a communications vehicle is pretty dramatic. That said, the need for cybersecurity, for high throughput, for other reasons, is getting very large. And so a larger community, and now we have many more competitors, a larger community is going, yes, we need to augment with optical communications.
So if I had a whiteboard in front of me, I'd get a little marker and I'd draw a satellite dish and then a satellite and I'd do a little communication going back and forth. So is your system that directional, or is it between satellites?
It can be both. Between satellites and space means that they're propagating through a vacuum, and so actually that's one of the easier problems, because the challenge then is just aiming. It's just pointing error. Whereas if you're going from space to ground, one has to go through atmospheric conditions, and that's the big challenge, and that's the hard problem we try to solve.
So optical communications can support both space to space and space to ground applications.
Yes. And air to ground, again, in numerous applications.
So what is an optical mesh network?
Optical mesh network depends on the application that one is talking about, but it's simply, for what the application I'm thinking you're talking about is, if you have optical links between satellites and they link each satellite, it's a mesh network, and they can send signals around. For example, if one wants a very low latency signal, they go satellite to satellite, or ground to satellite down, and they bypass much of the servers and routers in the internet.
You know, Barry, people from all over the world, China, Japan, India, all over the place, even Brazil, have listened to this podcast. If you're listening to this now and you want to get email alerts when the new episodes are available, go to Google, type in Constellations Podcast, go to Kratos, and give us your email, and we'll make you know what's going on next. I went to your website, Barry, and you talked about ground station site diversity. Why is that even important?
Oh, yes. So there's no free lunch, and all communication systems have their advantages and disadvantages. In the case of optical communications, optical wireless communications, we do work with atmosphere. We have to work with atmospheric conditions, and one of the classic techniques is diversity, having a multiple of sites that you go down on Earth in case there are weather conditions that don't allow coming to a very specific area.
I was doing research this morning about your company and your offering, and here in Washington, D.C., there was something like around 2000 called TSAT that was introduced and never got funded. Is this similar to that, or is it a different concept completely?
TSAT was a program that was developing optical wireless communications, and I won't go into details of where it didn't go, but needless to say, it was probably ahead of its time. And this is a key point, is that the time for optical communications does not appear to be ahead of itself anymore. It's the right time.
What do you think the hurdles are into all these companies in the flow here adopting your technology? What's the big challenge that they have?
I think the biggest is just awareness. I mean, we have to do advocacy so people understand what can be done, what cannot be done, how to work together with RF systems. For example, if in the satellite case, if a satellite is using optical comms to downlink and they run into a very severe weather condition, that there is the choice to actually use a lower rate RF system, X-band let's say, and use an adjacent site on the ground, so that if an image or a signal really has to get down, you can do that, and working through a hybrid system that is well managed.
Well, I keep thinking of software development and agile and flexible and pivoting and changing with requirements. It seems that it gives if we have a good situation, everything's clear, we can use the high speed or bump down to RF, providing you have that ground station site diversity, huh?
It's there's a corollary that we all know, and it's called your cell phone. Your mobile phone goes through multiple modes, and it picks the mode that is optimal, and then selects a mode that if conditions change, then the mode will select one that works in the conditions that are provided.
Before this interview started, I was chatting with you and you talked about your travel schedule, which is amazing. So I think that's what your job is awareness. You're awareness man. Yes. Hey, I'm here. Come over here. Let me tell you about my product. So you're on the road all the time talking about this.
It's important. It's important that people understand, whether it's the U.S. government, whether it's other countries. I think it was publicly announced that we have a cooperation with Smallsats in Qatar, and it's great that we can talk to them and talk about what we can do in the world of communications.
To me, if we look at your company, it seems like the wireless industry might provide a good fit for your offering, your technology. Can optical networking benefit the emerging 5G network space?
That's a great question, because the answer is a most definite yes. For front haul, back haul applications that using optical in some cases instead of millimeter wave, I think applies, and certainly we're advocating that.
Well, I wish I could define 5G by saying millimeter wave. It's just, I try to define it, and every time I try, okay, I'm not going to try anymore. And I call people to Verizon, and then the people AT&T give me another definition, and maybe Barry could give me another definition. Give me Barry's definition of 5G.
Well, I'll go with the millimeter wave bit first, and that's very clear. It's just a frequency band that is licensed. Going to 5G. 5G at the end of the day is about much lower latency and very high speed. Without that combination, 5G would just be a slight extension of 4G, but it's much more than that.
But as far as site diversity goes, there's a lot of infrastructure has to be built. That's why these big companies like Verizon are putting millions and millions of dollars into it, and AT&T. I just think of the different geographic areas of the world that have to be changed and altered. I mean, I guess I'm not as optimistic as the youngsters are about 5G. I think it's going to take a few years.
I can only suggest that with every generation that there's always been challenges. I remember when 2G transitioned into 3G, and there were a lot of challenges then too.
Do you remember when they would lay those cable crazy things in your neighborhood, and people would say, we're never going to use this stuff? And now they're used up?
The one thing, it really points to something on that. We talk about speeds now that are not megabits anymore. We're talking about gigabits, and lots of gigabits. And people go, how much do you use? How many people can use, 100 gigabits? And the answer is, actually, just give it a little time. It will all be used up, just like we do now with our phones.
I think they used to call it dark cable or something, didn't they? They had all this cable that no one knew was good, and all of a sudden now there's constant use for it. I think that's what's going to happen with the number of satellites going to be out the next 5 to 10 years is, what are we going to needs faster communications. Maybe that's where we're going to fit in. A lot of people fly from all over the world to come to the satellite show. Or Satellite 20. I was up getting some coffee. I heard like 5 languages and 5 people, all kinds of people all over the world. Do you think there's partnerships for you with this optical communication?
Around the world?
In this room.
In this room?
Yeah.
Oh, most definitely. I can't tell you who we've been working with, but yes, most definitely.
It's a secret, but it should be a secret. Believe me, it could be pick the country. There's 135 countries. I think everyone is here today.
And I can tell you that Saturday morning I'm on a plane to Europe.
Oh, there's a hint. Breaking news. Stop the presses.
Europe
call the Washington Post.
It's okay.
Stop the Washington Post or the Paris Tribune or whatever the heck it is. In Washington, D.C., we have these public-private organizations.
Yes.
And we have organizations like NIST that work in a lot of areas of the federal government, and they're respected outside the federal government. Is there an area in the public-private world that maybe you can apply some of this fast technology?
Yes.
Working with federal government? Yeah.
I mean,
I don't know the obvious ones.
With the government, there are some programs we can't talk about, but most definitely the government has applications across the board.
It's crystal ball time, and I always try to look in the future. And, Barry, someone like you have 20, 30 years in the industry. You're an entrepreneur. You have a real good idea of what this technology can do. So you must, here's the conclusion, you must have an idea of where it's heading in the next 5 to 10. There's no way. I get every booth I am at, every guest I have, I go, wow, I never expected that. So what are you going to tell me that's going to dazzle me 5 years from now? What are we going to look back at? Only gigabyte rates, or what's next?
Well beyond what's happening on Earth, in space, in the air, there's There's going to places like the moon. And if you're going to do lunar communications, you're going to have orbiting bodies around the moon. You're going to have a lunar gateway, and that lunar gateway will have an optical link to support the traffic that's coming from the moon. So we could expect that in the remember, we have a 5-year mission to get back to the moon.
5-year mission.
Yes,
and
so somewhere in that time frame, we can also have an optical connection, high-speed optical connection from the moon back to Earth.
You and I both have adult kids, and I think about kids all the time and talent. And so how do you attract the type of people that can understand what you're doing and make that emotional commitment and jump on board with your vision? You know, I think that's a real challenge here. There's some talent out there, but this is kind of difficult to articulate, I think, to the tech audience. Is it, or are they jumping on board?
It's not, because what everybody relates to is, I need the latest app. I need the latest game. I need something that can support the communications I'm doing. I need mass communications. Everybody understands that communications challenge. And then the next part is, well, how is it implemented? And that how is it implemented is evolving. Whether it's 5G, whether it's optical communications, it's going to continue to evolve. And so not only is optical part of that future, there are other elements that are coming together. Processing speed plus communication speed go hand in hand with how cell phones, other things evolve and become the modern technology that we all know now, and that is going to evolve in the future. So it's not difficult for me at all, because all I have to say is, how much eventuality you want in your future that all things are going to improve? The answer is yes.
It can happen. This is a part of it too. Well, Barry, unfortunately, we are running out of time. I'd like to thank our guest, Barry Matsumori, CEO of Bridgesat. Thanks, Barry.
Thank you.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.